To start our assembly training activity for SolidWorks, we're actually going to come to the assembling training folder. You do have a set of basic instructions that we start with. We're going to download something. We're going to extract the parts on a folder in your drive. You're going to follow this video to complete it. And then after you're done with this video, go ahead and go to the quiz assignment right here, and you're going to answer all the questions using your assembly. So basically, you will change some of the angles or distances or things we do in order to answer the questions they're asking you and provide the values they need. So first thing to do is to download the files. We're going to click here to download the files. It may ask you where you want to save them, but 9 times out of 10 it just throws it in download. So I'm going to go ahead and hit save so that mine looks as close to yours as possible. Now, if you're using Google Chrome, once it downloads, you can actually click on this and say Show in Folder. This should bring up your Downloads folder, and the training.zip is at the top. Now, this is a compressed folder. There's 4 different files inside, and you need all 4 files. That's why we did it this way. So, with it selected, you'll notice there's a pink tab at the top that says Extract. Okay, so if you go to the Extract section, you can click Extract All. Now, once you do this, it is going to ask you, where do you want the extracted files to go? Now, I would not leave them in downloads because that means it is on this computer, not on your network drive, so it's not getting backed up. So go ahead and click Browse. Find your network drive. If you have a folder where you're keeping all of our SolidWorks stuff, go ahead and go there. And I'm going to go ahead and make a new folder and call it Assembly. I already have one called Assembly Training. So I'll go ahead and give it Assembly Training 2, just because, again, I need a different name. So once I pick in here, I can hit Select, and I will hit Extract. Now the computer will take a second and it will send all those files, and you'll notice inside Assembly Training 2, I've now got AT Arm, AT Assembly Start, AT Base, and AT Pin. So it may actually work better if you open SolidWorks first, which I have done. So I'm going to double click on the one that is an assembly, AT Start. And what I've done as this is opening is I've actually already inserted the base piece for you. I did that so that you could see that when you open it, something is already there. The initial part is there. There's a few things I want to show you. I'm going to let this open. And once it opens, you'll have the green base piece here in your assembly. When you go to starting your own assemblies, this will start blank. Now, the first part that you bring in is fixed in space once you've clicked to set it down. If I click it and try to drag it, it won't let me. It's not going to move around. I'll also notice this because if you look over here in the file tree, you'll notice there's a little F in parentheses at the beginning. That means fixed. Now, if I was to unfortunately bring in the wrong part, I could right-click on this, and one of my options is float. Okay, and if I float it, then it's no longer going to be a fixed part. But I do need at least one fixed part in my assemblies for it to work correctly. So that's just fine. Now, what do I do to start bringing stuff in? So now that we're in a different file type in SolidWorks, we do have some different tabs that we have. So one of the first ones I'm going to introduce us to is this Assemblies tab. This is different. Now, some of these tools are the same. You can see reference geometry. You might see some linear pattern stuff, other things that you will recognize. Okay, but there's also going to be different ones that you don't. The first one we're going to use is Insert Components. So when we click Insert Components, these are going to bring things in. So one of the big things about assemblies is that every part needs to be drawn in its own parts file. So as it automatically opened it, because I don't have any parts open right now, you can see I have 3 different ones that end as a SolidWorks part file, or SLDPRT. The 2 that I need to bring in are ARM, and I'm just going to go ahead and set it down. And I'm going to click Insert again. and I will bring in the pin. I now have all three parts of my assembly that I need. Depending on what you're doing, you may have more parts than this. Okay, and as you can see again in my file tree, I've got different things that are showing. This one is fixed, and then the dashes show that those ones are what's called floating, meaning if I grabbed it and drag it around, it moves around, which is a good thing to know. So now we need to put this together, and as you can see, this is kind of like a little clamping type thing. So I'm going to want things to move. I'm going to want this blue arm to be able to move up and down. So I don't want to just fix everything. All right, I want to put some different requirements in. So one of the first things I'm going to do is I'm going to tell you, try to think about this kind of the same way you would if you were actually popping this together. One of the first things we would do is we would line up the hole for the arm with the hole in the base so that they are aligned. That is called a mate, right? And a mate is like a rule. It's similar to the relationships in sketching where we fix things in place using certain relationships. So the easiest way to do this is to click the inside of the hole. Click the cylinder part, which you'll see highlight. And you know you've selected the right part because it kind of goes this transparency weird color. Don't be surprised by that. It actually does that so that if there was something on the other side of it, you'd be able to see through and click to it. And then I'm going to click the inside of the other hole as well. And it's going to move them down so that they are lined up. When I accept it, I get a concentric mate. Okay. Now you will notice if I move this blue arm that it will twist and it will keep that relationship, but the two surfaces that need to be touching currently aren't. So if I need this surface, notice my mate tool is still open, to be touching this surface, I will click those two and I will give them the coincident mate. The SolidWorks mating tool is pretty good at guessing what you want. Every once in a while, you will have to tell it what you want specifically. Now, when I do that, if I drag this around, you can see that it will rotate there exactly like I want it to. Now, to add a little bit of reality, we're not just going to have this magic hollow hole be a rotational point. We're going to go ahead and we're going to put our pin in it. So the first thing I'm going to select is the cylinder part of the pin. Next thing I'm going to select is the cylinder part of the hole. And it's going to add the concentric mate again. Concentric is one we use a lot, especially when we're lining up pins and holes and pivot points. Another one that I'm going to do, and this again is going to be kind of familiar, is the back side of the bolt head should touch this side of the green base. So I'm going to put those two with a coincident mate. Now, the last part of this is I've got this hex head kind of like a bolt would have. Just perfect. Right now, if I grab it, it can spin. And I don't want it to spin. I'm going to pretend that this is maybe something we screw in. It stays put. So I am going to use a different style mate that we haven't used yet. I'm going to click the top surface of this and the top surface of this. Now what it guessed is that I want a parallel mate, and it's actually correct. That is what I would use. But I could also use a distance, an angle, something else. Distance would be kind of rough because then it'd kind of try to pull it out of the hole. But if I wanted that surface to be at a 45-degree angle from the base, I can actually switch to an angle mate and tell it to be 45 degrees, and it would rotate it to that position. Now that's not what I want. I do want the parallel mate. So basically it's another way of creating this as a horizontal arrangement. So as I accept that, if I go to try to twist this now, it tells me I can't do that. As soon as I click on it, it starts to tell me, nope, you can't do that. That is fixed. You will even see that my little dash for the pin has disappeared. That shows that that piece has been fully defined. Now, do we want everything fully defined in an assembly? Not necessarily. For example, I already told you we're going to want to rotate this arm. So I don't want this to get fully defined. Now I might use some mates that temporarily define it so that I can find out some information. So let's just go ahead and go to our front view and look at some of the mates we may use to fix these two jaws in place, especially if I get a question, something like, well, what if these are a certain distance apart, or there's a certain relationship, or there's a certain angle? And that's where I'm going to use my mates to try to figure this out. So for example, I might get asked something about, well, if the two jaw faces are so many degrees apart, what is the distance, or what is the center of mass, or something like that. And to do that, I like to come down to the front view, because then I can very easily click the edge of this one and the edge of this one. Now, if I make them parallel, that'll bring them down to where they are parallel. And this will work great, especially if I get asked a question like, hey, if the two faces are parallel, what's the distance? All right, and if you get asked that, what you can do is you can accept that, get out of your mates tool, go to evaluate and measure. And if you get asked a distance, by the way, I've expanded mine. You don't necessarily have to do that. If I click one, then the other, okay, I will get the distance between them. I'm not going to do that because that might be on your test and I want you to do that yourself. I can then close this and those lines go away. Now, what happens if I need to change or remove or adjust those mates? If you look in the file tree, right next to the word mates is a drop-down arrow. If I drop this down, this shows all the mates that I've used for this part so far. So if I go to my parallel 3 mate and I go to edit feature, not only can I edit the parallelity or which surfaces are selected, I can also change to a totally different mate. Now you'll notice some of my mates are grayed out, and those are ones that cannot be applied based on the fact that I've picked 2 edges. I could make them coincident so that they were touching. Oh, nope, it won't let me. Could make them perpendicular, which, by the way, if I go down like that and I say, no, I wanted it straight up in the air, I might be able to change the arrangement or flip that. So I'll flip it first, then change to perpendicular. Oh, it doesn't like that. Okay. I'd actually, if I was having to stick that straight up in the air, I'd have to do that a different way. Now, the other thing I can do is switch to distance or angle. So if I switch to angle, sorry, I don't want to flip that around, and I get told something like those 2 surfaces are 30 degrees apart, I can type in 30 degrees. If it goes the wrong way, I just switch my angle alignment. Now, you may get this, and this happens sometimes where I might need to actually delete a selection to change the order. And it's not going to let me change the order. So if you need to get rid of a mate, delete your mate and move whatever around you need to. And we're going to add it again. It was kind of interesting the way it did that. I'm going to pick my edge and my edge, and I'm going to tell them to have a distance, or sorry, an angle, and I'm going to set it at 30 degrees. I don't know why it liked that better. I do see that I picked the arm first, so maybe that had something to do with it. But then I can pick that out. And again, I can find a distance. I could find a distance to a certain other thing. There's a whole bunch of different things that I could do with this. Now, just not that it would necessarily matter with this, but there's many assemblies, especially on things like the CSWA exam or stuff like that, where you may need to see inside like a cylinder, like if there's a circular cylinder with like a piston or a hole in it or something like that, and they may be asking you to either measure that distance or set that distance with a mate. So either way, there might be times where you need to kind of see inside to do a mate. So as we look at the top, and I can't do it with the mate tool on, you'll see the thing that looks kind of like half a cake. Right here, it's called section view. And if I turn this on, it's going to take a plane and it's going to allow me to kind of move this and see inside. So if I wanted to see inside my assembly here, I could bring this to there, especially if, again, if there was something inside this piece that I wanted to measure the distance between or set the distance between, then I can just pull it all the way. And so I can take this and kind of cut it. Now, if this isn't facing the right way, I can rotate the plane, okay, in a different direction, and then switch back to the arrow and use it to push and pull to see the inside. So this would allow me to see like the inside here. And again, I could add a relationship. I could measure something. I could do something to that effect. So there we go. That's how we do everything. Oh, and you just, to turn section view off, you can just accept it or close. And lastly, just like in your parts files, under evaluate, you do have mass properties, which will tell you the mass, the center of mass, and various other things as well. So if you do get asked anything about center of mass or any of those mass properties, you can look at it just the same way you do in a regular part. Okay, so you should save your part as you're doing this, because you can come back and finish it if you start one day and need to finish answering your questions another day. Good luck, and feel free to reference this video doing other assemblies as well. Real quick, I figured out that I ended my video without showing you a very important task that you will be asked to do at some point in your test for this project. So if you go, I'm going to go back to my front view. I didn't have SolidWorks selected when I told it to do that. I am going to remove my angle mate. So again, I'm going to click on it, delete. It's going to make sure I'm sure. And the mate that I'm going to add is going to be kind of an interesting one. I'm going to turn just slightly and assembly and mate. And I'm going to take this top edge of the arm and that top edge, and I'm going to make them parallel. Okay, great. So when I look at the front, that edge is now parallel to the top of this. Cool. Now, if you were asked, what angle is this? You would have really no way of telling unless you figured out something different. So when I do measure, so if I go to evaluate and I try to click measure and I try to click this edge and this edge, it'll tell me the distance, it'll tell me the straight distance, it'll tell me the vertical and the horizontal distance. The one thing it doesn't tell me is the angle. I feel like this would be a real easy thing for SolidWorks to add, but they don't have it there. So what we have to do is we have to go to layout, okay? And there's smart dimension. Don't go to sketch, go to layout. And under layout, there's smart dimension, and I can pick this edge and this edge and get the angle in between. Now, when I do that, it's going to look funny, okay? I don't know why it just reversed itself, but it did. Here's some things that you want to fix before you try to answer a question, okay? First off, I want my tolerance to be none, okay? Second, I want my decimal place to be none, okay? So if I do none, none, or if you are instructed to use like 3 decimal places, you can use 3 decimal places. That'll give you the angle, okay? So really what we want to get rid of is we want to get rid of the tolerance thing, and I want to be able to see, I want you to be able to say, okay, if I need 1 decimal place, 2 decimal places, 3, okay, or none, whatever it is you need, okay? So that's the way, that's what that will tell you. And if now instead of a parallel mate, it gave me an angle, sorry, let me get completely off of it. It gave me an angle or something instead, like 10 degrees, okay? I can see that as it changes because I use that distance measurement. Okay, oh, that goes completely the wrong way. This is again maybe where if I wanted it to be 10 degrees, instead of this coming 10 degrees down, if I wanted it to be 10 degrees up, well, let me actually just try negative. Nope, it doesn't like that. Okay, well, figured I'd try it. But anyhow, that's how you can measure an angle, and you'll probably see something like that on your test. Good luck.